Hey there, in this video we're going to learn how to read data out of text files and put them into NumPy arrays. We have already learned how to open files and how to read them in Python, but NumPy has a couple built-in functions that let us do that all in one step and directly open the file, read the file, put it in an array and close the file, so all built in for us. To begin with, we're going to need some kind of text file to read. We could create it step by step, but I want to show you a trick where you can create short text files using your Jupyter Notebook. And we can do that with a special command that starts with two percentage signs called a magic command. This particular command is file. I think if we just do %% and tab a few times, does it? There we go. We can actually get a list of what all these commands are. Ignore all the ones that start with one or more underscores. These are the ones that are meaningful to us. In any case, the one we're going to use here is file. And if I hit Shift Tab, it'll tell me this is the same thing as write file. I usually just use file. And write file lets us write the contents of a cell to a file. Okay, so we'll just do %% write file or %% file. I'm going to call this file phone numbers.txt. And then the contents of this, I have them off here to the side. Let me just copy paste. So I've just made up some phone numbers. Okay, if I run that cell, it's going to create a new file for me, phone numbers.txt. And if we go over here and look, we can see it appears in my file browser. There it is, ready for me to use. So that's another way we can quickly create a text file. Anyway, what I really want to focus on is how we can read that and put it into a NumPy array. So the two functions we're going to use here are load text and gen from text. Let's start with load text. It's the simpler of the two. So load text has to have a file name. We have some other options here, many of which are useful. So like delimiter here defaults to looking for spaces. We got empty spaces in here to separate the data, but you could change it to be a comma if your file used commas. Skip rows if you want to skip the first few rows, like say you had a header. And another one, or some other ones that we'll look at later. But for now, what we really need here is the file name. So I'm going to load text, and the thing I'm going to load is phone numbers.txt. I can use tab completion to finish that off quickly. All right. So now A should have everything that was in phone numbers.txt. And it does. It looks actually just like the file. Now, depending on what you want, that might actually be kind of aggravating. I mean, the phone numbers are not 185.265. Instead, the phone numbers are reading down the columns like 8675309. That's the phone number. And so we could say that this is sideways. That's a little annoying. So the way we can fix that is using one of those arguments in there. So let's just reuse this cell. So remember, we have this list of arguments here. The one that's really, really handy here is the argument unpack. Okay, if we look down here, see what unpack does. If true, the returned array is transposed, so that means rotated. And that's so that we can unpack them using XYZ equals load text. This is tuple unpacking. This is super powerful. Okay, so that's what we want. So I want to do unpack equals true. And it's not so much that I just want to put it in A. I mean, I can do that and I'll get a sideways array here, but much more powerful is if I do ABC. And then I print A, print B, print C. What I'm going to get there is I never ran the cell. That's why. Okay, so I run the cell first and then print A, print B, print C. Then I have array A is the first phone number, array B is the second phone number, array C is the third phone number. So that's hugely powerful. It lets you put each column. What this does is it puts each column into an array. So this might be like X values, Y values, and I don't know, energy. And then you can unpack it and load them with tuple unpacking into individual arrays. All right, so that's load from text. Quickly, let's look at gen from text. So very close cousin to load text. The only difference that we see right away is there's a lot more options in here. Just a more powerful text parser. It lets you handle more things than load text, in particular things like missing values. Like if you had just a space in here, load from text is going to die when it sees that, because it's not going to know how to put an empty space into the array. Or if you have nans and there are not a numbers in there, it's going to die when it tries to put it in the array, or your calculation will die when it tries to use it. This can detect that kind of thing and fix it for you. Also, like characters you want to strip out from the file. Lots more options that all depend on how messy the file is that you're reading. Because really, when it comes to loading a file, it's not loading the file that's hard. It's having the file be in a format that makes sense that's hard. Typically, your data files will not just have spaces between the data. They'll have something like commas, they'll have headers, they might have space, they might have missing data in them. And this gen from text just gives you a function that handles all those different parsing options all in one. All right, so in this video, we looked at how we can open up a text file and load it into NumPy arrays, and we can do this extremely efficiently if we use this unpack argument, which also works with gen from text, and then tuple unpacking to put each column into its own array.